All right, so for this video, we're going to be talking about writing quadratic equations in factored form. So we're really going to talk about a bunch of different scenarios and what factored form is. So factored form means that we're able to identify the factors of a quadratic just by the factor and what the number is itself. So the factored form is a, and then we're going to have x minus m times x minus n. Now, what you need to understand is that when we look at these, we have the a value. Now, my a value is still going to represent the general shape. So when I say the general shape, the a value is going to tell me, and the a talks about whether it's going to open up or open down. So remember, if a is positive, it's going to open up. If a is negative, it's going to open down. So a still describes the general shape, and the a is also going to tell me whether or not it is going to be it's going to be skinny or is it going to stretch, that kind of information. So that a value, if it's greater than 1, then it's going to be a vertical stretch. If the a value is less than 1, then it's a vertical shrink. All right, so the new pieces of information that we're going to look at is the m and the n. So the m and the n are going to represent the factors. So those factors they can be called solutions. They can also be called the x-intercepts. They can be called the roots, or they can be called the zeros. These are all meaning the same thing. So if any of these words mean the same thing, but ultimately graphically it means the x-intercepts. Okay, and they're called the zeros because that's where it crosses the x-axis, where the y value is 0. So what we're going to be looking at is we're going to be looking at writing a quadratic in factored form if I give you a point and the solution. So a point on the quadratic and the x-intercepts basically. So how would we go about doing that? Well, the first thing you're going to do is you're going to write the factored form formula. Now, that factored form formula is that a times x minus m times x minus n. Okay, so based off the information, you're going to substitute that information in. Okay, so then at that point, you're going to identify or you're going to label all your parts. You really need to make sure you know what pieces go together. So you need to know what is the vertex, what is the point, or what's the solutions, the x-intercepts. You need to know what is the point that it's actually going through. Now, once you are able to label all the parts, then you're going to substitute those values into my factored form formula. So remember, substitute means that you're going to then after you substitute all of the parts, that's when you're going to solve for a. Because the whole thing is here is that's what we'll be missing, is we're going to be missing the a. Now, after we solve for a, that means that we're going to substitute everything back into the formula except for the x and y from the original point that was given. So we're going to work through this problem right here, and we're going to look at each step, and I'm going to kind of color code to walk you through it. So we're going to write the factor form formula. So again, the factor form formula is a equals x minus m times x minus n. Now, the next thing we need to do is we need to label our parts here. So we want to label the information that is given. Okay, so it says that the parabola passes through the point 6, negative 2. So 6, negative 2, that's my x and that's my y. It also tells me that my solutions are 4, 0, and 8, 0. So my solutions mean that these are my m and my n because of the fact that it says solutions. Those are my x-intercepts. Okay. Now, we're going to take that information and we're going to substitute that into the problem. So if we substitute that into the problem, we're going to have all of those pieces together, and we're going to have, so, sorry about that. So my y value is going to be negative 2. We do not know my a value. We have an x value. So my x value is 6 minus my m. My m is 4. Then we have a 6 again for the x minus my n value. And at that point, we're going to solve and simplify. So we have negative 2 equals a. 6 minus 4, that's also going to be 2. And then we have 6 minus 8, which is going to be negative 2. So I have negative 2, and then 2 times negative 2 is going to be negative 4a. And I'm going to just put it in front as a coefficient. And I'm going to finish solving, and I'm going to divide by negative 4 to get what the a value is. So my a value is equal to positive 1/2. Now, I know my a value, so all I have to do at this point is to substitute. So at this point, I did solve for a here, and I started solving for a at this step right here. Okay, so once I have my a value, I can plug everything back in to my original format. So I know my a is 1/2, and so I have x minus my original 4, and then I have x minus my 8. And the reason it's minus is because that is the original formula. Now, if I have a number that's negative and I substitute, that's when it'll change into a positive. All right, the other thing that we need to look at is let's look at it graphically. So if I'm looking at Desmos and I put in my form or quadratic that I found, so I have 1/2, I have x minus 4, x minus 8. All right, so it told us that we have in this problem, we have those original solutions at 4 and 8. So I can see those x-intercepts, they are in fact crossing at 4 and 8. And it told us that the original point that was in the problem was 6 and negative 2. So if I look for 6, negative 2, I can see that that point is on the graph. So we are in fact correct here. All right, so with that being said, we should now be able to look back, and we should be able to see that we were able to substitute the given information. And once we substituted in that given information, that information provided us with the a value to complete the factored form. Now remember, factored form of a quadratic is when I have my x-intercepts already in that x minus m, x minus n, and the a value out front if there is an a value. Okay? Now, as a review, if we're converting factored form to standard form, okay? So remember, standard form is ax squared plus bx plus c. So let me remind you again, standard form is ax squared plus bx plus c. Now, in order to do that, we're going to do something very similar that we did when we had vertex form and we went to standard form. So we're going to multiply, and we're going to multiply the binomials. Those are the factors that are in the parentheses. So when we go to multiply the binomials, we are multiplying these pieces together here. So we're going to start with these two, and we're going to multiply those together. Now, you can either use the full method, just because it is a binomial, or you can use the box method that we talked about previously. I'm going to go ahead and use the box method, but just as a habit of what I use in my other classes. So we're going to take the two parentheses, and we're going to multiply those pieces together. So I have x and negative 3, and then I have x and 7. So if we multiply x and x, that gives me x squared. X times 7 is going to be 7x. X times negative 3 is negative 3x. And then negative 3 times 7 is going to be negative 21. So that now gives me y equals 2. And then we're going to combine those like terms there. So that's going to be 7x and negative 3x is 4x minus 21. Okay. So once we do that, again, we said combine like terms. So we combine any of the like terms that we have together. All right, and just to kind of keep with our color coding, I'm going to use the box method, which is what I did here. All right, so once we were able to combine our like terms, we're now going to do the final step, which is to distribute the a value. So the a value in our problem is a 2. So we're going to distribute that 2 into the rest of the polynomial that we have created here. So we're going to distribute the 2 to the x squared, the 2 to the 4x, and the 2 to the negative 21. So that's going to give me a final answer of 2x squared plus 8x minus 42. So we've taken this factored form and we've converted it into standard form. So we're going to do some more examples here, and we're going to be looking at, they're giving us the solutions and they're giving us a point, and they want us to write it in factored form. So we're going to do what we did before. Now, when they write solutions like this, you see how it's put in set notation? That set notation does not mean an actual point. That means that it's the two solutions, which would be 0, or sorry, not 0. It would be negative 3 and 0 as a point, and it would be 1 and 0 as a point. So just keep in mind when they list solutions like that in those set notations, they're just listing the numbers of where it crosses the x-axis. So what we're going to do is just like we did before, we're going to use our factored form. So we have x minus m times x minus n. So I'm going to identify my information here. So remember, this is going to be an m and an n because they've listed these solutions, okay? And then my point is going to be my x and my y. So we're going to substitute that in. So I'm going to substitute in negative 3 and negative 3 for y. We don't know the a. We know the x value is negative 5, and we're going to subtract the m. Now remember, the m is a negative 3. We're going to also substitute the x value again, and we're going to subtract the n, which is 1. Now, we need to simplify this, and we need to solve for a. So if we simplify this, then I need to say negative 5 minus negative 3, so that's technically going to be negative 2. And then we have negative 5 minus 1 is going to be negative 6. All right, so we're going to keep solving for a here. So we have negative 2 times negative 6. That's going to be positive 12. So we have 12a. And then we're going to divide by 12. Now, when we simplify this, we should get that a is negative 1/4. So at this point, we're going to finalize our answer by plugging everything back in. So we have our a value is negative 1/4. Now remember, we don't substitute the x and the y this time. We're just substituting the information to write it. So the original m was a negative 3. Now if I have minus a negative 3, that's going to convert in just a second, and I'll show you how. And then we have x, and our n is a negative 1, so, or positive 1, so we're going to subtract that. Now, what happens when we have minus a negative? That's going to turn into x plus 3. So just keep that in mind. The opposite sign when you substitute, it's going to look like the opposite sign when you substitute it in, because the original formula is in fact a subtraction sign. Okay. All right, so let's look at the next example. Same situation. We have our solutions are at 0 and 6. So again, that means that I have a solution at 0 and I have a solution at 6, 0. So the actual points are those, but these are your m and your n. This is your x and your y that goes to that point. All right, so if we start with our original format of a times x minus m times x minus n, we're going to substitute what we have in this problem. So my y value is going to be negative 9. We do not know the a value, which is what we're trying to find. The x is negative 3 minus m is 0. Then we have another x of negative 3 minus 6. And then we're going to simplify. So we have negative 3 minus 0 is still going to be negative 3. And then we have negative 3 minus 6. That's going to be negative 9. So if we multiply that together, we have A equals 27. And again, you can write it like that or you can put it in front. But we are going to divide here. And we should get an A value. And my A value is going to be negative 1/3. So now I just finalize by putting everything back into the original problem. So I have negative 1/3 for A. All right, then I have X. My original M was 0. So I can write minus 0, but I definitely am going to want to simplify that later. Then I have my 6, so X minus 6. Now that minus 0 is not necessary. So we're going to say negative 1/3 X. And then times X minus 6. All right, so this last example, obviously it's formatted where they actually give you the solutions. Again, they could format it where they did the set notation and just list what the solutions are or the x-intercepts. All right, so we have y equals A times x minus m, and then we have x minus n. All right, so we know that this is my x and my y. We'll call this m and this one n. So we're going to substitute those values in. We're going to say that the y is 9. We're solving for A. My x is negative 2, and this is minus negative 5. My x is negative 2 again, minus my n, which is negative 3. And then we need to simplify. So I have 9 equals A. So negative 2 minus negative 5 is going to wind up being positive 3. And then negative 2 minus negative 3 is going to wind up being a positive 1. So 9 equals 3A. Divide by 3. And we get the A value is positive 3. So at that point, we put it all back together. So my A is 3. My X, original M, was negative 5. So at this point, if you kind of gotten the pattern, you don't necessarily have to write it as minus a negative 5. You can just go ahead and put X plus 5. And my other original was negative 3, so we can put it in as the opposite. Now, let's kind of go back to Desmos and let's look at some of this information. So we have y equals 3. We have x plus 5 and x plus 3. And I forgot the 3 value. So we can see that they did cross that negative 5 and negative 3, given the fact that they gave us the intercepts. And they told me that the point of that was on the graph was negative 2 and 9. And again, I can see that that is a point on the quadratic. So any of these, and my A value was positive, and it is opening upward. So if I go back to this one, we got negative 1/3 times x and it was x minus 6. Okay, so we can see that it's opening downward. It also told us that, so my x-intercepts are at 0 and 6, which is true. And it was going through the point negative 3, negative 9. So I put a negative 3, negative 9. I can, in fact, see that point is on the quadratic. And again, if I wanted to take this quadratic and I wanted to turn this into standard form, all I would have to do is multiply this together. All right, so if I'm able to get it in factored form and I want to convert it to standard form, all I would do is multiply my binomials together and then distribute. So we would say the x plus 5, and then we would do x plus 3. So we have x and 5, x and 3. So that would be x squared. That would be 3x, 5x, and 15. Okay, so we would have y equals 3 times x squared plus 8x plus 15. And then at that point, all we would have to do is distribute the 3. So if we distribute the 3, that would be 3x squared plus 24x plus 45. So you can convert between any form that you like depending on which one's given or which one you're looking for. Now, so if I have some tables, so if I have a table, remember there's 3 things that we need in order to write my factored form. So we need 2 of the x-intercepts, okay? So we need 2 x-intercepts and we need 1 point. So when I look at a table, an x-intercept is always going to have a y value that is 0. So y value of 0, okay? So when I look at my table, I can see that I have a y value 0 here. And I have a y value of 0 here. So that means that -2 is the intercept and 3 is an intercept. So that's going to be my m and my n. So I can say that I have -2, 0, and I have 3, 0. Now, we also need a point. It really doesn't matter which point you choose. Pick any point. Pick any point. So I'm going to go with, let's say, 0 and -6. Or excuse me, 1 and -6. All right, so if I choose 1 and -6, that means that's going to be my x and that's going to be my y. And we're going to do what we've been doing. We're going to substitute it into the formula. So my x value is going to be -6. Okay. And that's going to equal the a, because we don't know the a. My y value is -6. My x value is going to be 1 minus my m. We identified that as -2. And then 1 minus my n, which is 3. And then we're going to solve. So -6 equals a times 3 and -2. All right, so when I look at this, I have -6 equals a times -6. And of course, if I divide that, that's going to equal a positive 1. So I can finalize my quadratic that I would have found in factored form. So I can write the 1 in front, but it's not necessary. But I would say x plus 2, x minus 3. So that 1 in front, again, is not necessary. I would just write my 2 factors. All right, same rules apply if I have a graph. All right, so we have our x-intercepts, and our x-intercepts are at -7 and 0. And at -3 and 0. Now, when we go to pick a point, we want to make sure that we're using a perfect point. Now, if I look closely, so my first instinct, oh, well, here's a perfect point. And it looks pretty close, but if you notice, it's off just a tad bit on that problem. So we always want to make sure we pick a perfect point. I do have some perfect points already identified. That perfect point is going to be at -1 and 9. Okay, so we have -1 and 9 there. So we're going to substitute in what we know. So this is my x and this is my y. So we know that we have a y value of 9. That equals a. And then we have an x value of -1 minus -7, which is my m. So again, just to be clear, this is my m, this is my n, because those are where it crosses the x-axis. And then we have -1 minus -3. And if you've gotten the pattern where you can just realize that the negative is going to be plus, then do that. So I'm going to simplify here. So a is going to be a times 6, and then times 2. So I have 12a once I simplify, and 9 and 12 are both divisible by 3. So we have a equals 3 over 4. So if I put everything back together, I have 3/4 times x plus 7, and then x plus 3. So equations, obviously, or if they're given to us, we can put the pieces together. If I have my graph or my table, I can still identify those pieces. All right, so we have the standard form. If I'm converting this to standard form, remember we're converting this to ax squared plus bx plus c. All right, so we're going to start by multiplying our binomials together. So when we multiply those binomials together, we're going to be multiplying the x and the -4, and then the x and the -2. All right, so that's going to give us x squared, -4x, -2x, and +8. So we're going to combine those like terms. So we have a -2x and a -4x. So that's going to make x squared minus 6x plus 8. But we need to distribute that -1/2 into my problem. So we're going to distribute the -1/2, and we're going to distribute it to every term into the parentheses to turn this back into standard form. So this is going to be -1/2 x squared. So half of 6 is 3, but a negative and a negative is going to make +3x. Half of 8 is 4, but that's going to turn that into a -4. All right, if you have any questions, please let me know, and I'll be more than happy to help.